let's move to the next topic, which comes under this equilibrium. So I will quickly go through the previous topic in a very short way. Then we will continue with this next topic. So we start actually with the equilibrium. So equilibrium of the two similar charges. So the main heading what we have learned is equilibrium. Now here we have like equilibrium of the two similar charges. So we know like where we have to place the third charge so that the third charges will comes to in equilibrium position. So as a summary, we have two charges. I will say Q1 and Q2. Two charges will be there. If both charges are like charges, either both are positive or both are negative, what is the conclusion for us? The third charge, suppose whose value is Q0, must have to place in between the two charges. Okay, if both charges are positive or both the charges are negative, third charge must be placed where? In between the two charges. If you are placing the two charges like this, then what will happen? The third charge will comes to an equilibrium position. And we have last class we have derived, the last sessions we have derived, if the total distance is L meter, then the distance from Q1 or the first charge, we also call it as low charge, QL, low charge, and this we call it as Q high, high charge. Okay, so this is like a X meter from the low charge. So we got X is equal to L by 4 with the help of an example. So we also will have a shortcut method for that to find out the values, right? What is the shortcuts we have learned? Root of QL, low value, divided by root of Q high value plus root of Q low value. Remember this one. This will save a lot of your time while you are writing the entrance examinations, because we cannot do the conventional method by applying the forces and do the calculations and all. We don't have time. So what we will do, we'll go with this method. Like low value means out of this one, which one is a low value, and this is also denominator high value. So root of QL divided by Q high plus, I'll make it clear, it is QH, Q high plus Q low. So apply these values and you will get the value of X. X is the distance from the low charge. Here Q1 I consider as low and Q2 I consider as high. So this X distance, this is nothing but X will be equal to, multiplied with the total distance, X equal to root of QL divided by root of QH plus QL. So this you have to remember, note it somewhere on your notebook in a highlighted way. So you have to remember. So this is applicable only if both the charges are like charges. Okay, either positive or negative. This is a short summary what we have seen in the previous sessions. Just I brush it up. Now we'll move to the next topic. So what is the next topic? Next topic is says, the next topic is says is just the reverse. Reverse in the sense, now the two charges are not equal, two charges are unlike charges. I'll take with an example, with the same example we'll see Q charge, okay, Q low charge I'm taking, and here I'm taking 9Q charge. Okay, both are same, but only difference is sign conventions are different will be here. One is plus, another one is minus. Okay, this is similar to Q1. In this case, Q1 equal to plus Q and Q2 equal to minus 9Q. Okay, we can take any example. In the previous sessions, we have taken example for Q1, how much we have taken? We have taken Q, and Q2, how much we have taken? We have taken 9Q. So same way, here also we can use any of this one, but just as an example, I have taken these values. But the only difference is like the sign conventions are different. Now we will try to see where the equilibrium position for the third charge is possible. So the equilibrium positions for the third charge where it is possible. Before going to this one, we'll write the heading. Equilibrium is the main headings, as we know, we have discussed in the last class. And equilibrium of which charge? Of the third charge. Equilibrium of the third charge. Equilibrium of the third charge when two other charges are opposite, this means, as like I told before, it is plus q and plus 9q. Two example values I have taken. As I told, this is q1 and this is q2. So we have two charges will be there, plus q and plus 9q. Now we'll apply not plus, this is minus, right? The two other charges are opposite. Opposite means one is plus and one is minus. So this is plus and this is minus. Now we'll see what will happen. In the previous sessions also I told, if two charges are equal charges, okay, then where will be the equilibrium position for the third charge will come? The answer will be definitely the third charge equilibrium position is in between the other two charges. It is not at the left side, it is not at the right side, but definitely it is at the middle. Not exactly at the middle in the sense in between the two charges, that's all. It is not at the exactly at the middle, it may be somewhere, but definitely it is very closer to the less charge. If q1 is lesser means it's very closer to the q1 charge. Now here situation is different. Here also we need to find out where the equilibrium position will come first. From there we will start and we'll find what is the value of something like called x. So now we'll take three positions we have. The left side position here, and somewhere in between the two charges, and the another position is a right side positions. Okay, now I am assuming my third charge value is called q0. My third charge value is called q0. If I have placed q0 will be here, what are the direction of the forces are acting on the body? q0 will be placed, okay, q0 is placed on the left hand side, so q0 is placed will be here. Now I am assuming q0 has positive sign. If q0 will have positive sign, because of plus q, q0 will move towards left with a force called F1. I am keeping it as F1. Okay, and because of minus 9q, q0 will attract, because this is plus, this plus with this plus will repel, plus q0 and minus 9q0, what will do? It will attract. So there is another force which is given as F2. Now two forces are in opposite direction. Here we have a chances of equilibrium, which means that what? F1, when F1 equal to F2, both forces are equal, there is a chance of equilibrium. So there is a chance there on the left side of the lower charge. Okay, left side of lower charge there is a chance. Now we'll see middle side. In the middle portion, is there is any chance these charges are come to equilibrium. Now instead of placing q0 will be here, I am placing q0 will be here. Now what will happen because of plus q? Plus q with the 9q0 repel, both are equal charges, so that is called F1. Minus 9q with the q0 will attract, so minus 9q0, it is moving towards minus 9q. Which charge will move? q0 will move with a force called F2. Here both forces are equal direction. Any chances of having will be here, these forces will cancel each other? Never, because both forces are acting in the same direction. Resultant force will never become 0, which means this center portion in the sense in between the two charge position for q0 is not a possible position for q0 to attain equilibrium position. So left side may be an equilibrium position, but the middle of the two charges will not be an equilibrium position. Reason is that there is a total net force is acting towards right. Because of this one, this will never comes to an equilibrium position. Now we'll see what will happen right side. Right side is there is any chances or not, we'll see. So here also we'll place the charge q0 will be here. So because of plus q and q0, there is a one force, repulsive force F1, and plus q0 and minus 9q, it is attractive force, so F2. Here also you can see two forces are there which are acting in opposite direction. So here there is any chances of equilibrium is possible? Yes, here there is a chances of equilibrium when F1 equal to F2, two forces may be equal. If it is equal, this charge can't move, this charge is in equilibrium position. But when come to here, the center position or the middle positions or the line joining between the two charges, in between the two charge position is not at all possible, because there is no chance to get an equal and opposite forces. Both the forces are acting in same direction. So I can say this may be an equilibrium position because opposite forces are there. This never become an equilibrium position. And I have one more chance, this become an equilibrium position. So there are two chances I have to have an equilibrium position, either towards the left of the lower charge or towards the right of the higher charge. Higher charge in the sense I am telling the magnitude wise, 9q, this is q. Sign is different, but magnitude wise this is 9q. So there is equilibrium position either towards left or towards right, but it will never become in between the two charges. Here we have another challenges. Here we have to confirm where actually the position will come, whether it is towards left or it is towards right. We have to have a concrete point where I have to say, okay, it is at left, it is at right. So I want to decide. Now we have two chances will be there, either towards left or towards right. Which side this will come? Can you tell me some logical explanations for this one? Now, if you see, will be here Q0. Okay, Q0 will be there, Q will be there, minus 9Q, and here also Q0. So two chances. So center point, no chance. We go out of our scope. So now if I am placing Q0 will be here, we'll consider this distance will be here, right? So how many forces are acting on the body? F1 force and F2 force. Two forces are acting on this body, F1 force and F2 force. Correct. Now what is the F1 force? F1 force is because of plus Q and F2 force is because of minus 9Q. So because of plus Q, if I am taking the distance, the formula, what is the formula? 1 by 4 pi epsilon 0 Q1 Q2 divided by x square. X square in the sense x I have taken the distance between them is x. Okay, so I will get one force formula. F1 will be equal to 1 by 4 pi epsilon 0 Q0 into Q divided by x square. And what is F2? F2 is a distance from here to Q0. This distance I am assuming as L. If I am assuming this as L, what is the formula will come? 1 by 4 pi epsilon 0 Q0 Q divided by total distance to this charge. Already this distance is L and this distance is X. So what is the total distance? X plus L the whole square. We'll keep it here. Middle position, no chance. So I am not writing the equations. I leave small gap will be here because it's not applicable, just to understand that. We'll move to the right side. Right side will have an F1 force. F1 force is because of which one? Because of plus Q. So this distance is also I am considering as X. So F1 will be equal to 1 by 4 pi epsilon 0 Q1 Q2. So what will come? Q into Q0 divided by, what is the total distance from Q0 will be here, and this distance to, Q will be here, Q to Q0 distance. So totally here L plus X. So L plus X the whole square. We'll move to F2. F2 is what? F2 is the force acting on Q0 because of minus 9Q. So 1 by 4 pi epsilon 0 Q1 Q2. So Q into Q0, first charge into the next charge, 9Q. 9 is minus 9Q whole divided by, what is the distance between the two charges? Again X square. Now we have all these equations will be here. Now if you see, X is a very small number. Q0 is fixed. Suppose I am assuming Q0 will equal to 1 coulomb. Just I am assuming for my understandability. For your understandability, to make the things easier, I am assuming 1 Q0 or just Q0 equal to 1 coulomb. So F1 equal to 1 by 4 pi epsilon 0 Q0 into Q divided by x square. X is very small. If x is very small, the numerator is also small. So the force is, this is a small quantity. If this is small means F1 will be higher, and this is also smaller. If this is also smaller means F1 will be lower. So this is a reasonable value, I can say. Now if we come to F2, F2 will be is a force due to, here one mistakes will be there, right? F2 is a force due to F2. This is a force due to minus 9Q. So instead of Q, here we have to put minus 9Q, because here Q and a Q0 force this one. Here Q0 and minus 9Q. Now if you see here, your denominator is a very higher value. X plus L. X plus L is a higher value. So what will happen? F2. F2 will be a lower value. But in the numerator you have Q will be the Q0 and 9Q. So both are total value will be equal to here almost 9 into Q into Q0. It's a negative value. Negative value indicate the force direction is opposite. That's all. So because of the numerator higher value, the force is also will be higher. So here also some reasonable values are coming. One is making low, another one is making higher. Because of this higher value, force is going low. Because of the numerator quantity, force is going high. So there is a balance will be here. If you see will be here in F1 case also, X is very small, so force will be very higher. But Q0 and Q comparable to this numerator part, here it is 9 will be there extra. Here there is no 9, so the numerator is less, so force is also less. So here also we can see some balancing. Okay. So which means F1 may equal to F2 because of the balancing. There is a chance will be here. But if you go to right side, we'll see 1 by 4 pi epsilon 0 Q into Q0. Here numerator is less. There is no 9. Numerator is less means F1 is less. L plus X the whole square means denominator is a higher value. If denominator is higher value means F1 will further going down. So F1 is very less. Now if you go to F2, numerator 9, so already it's a higher value. Denominator is a smaller value. Again it's a higher value. A very higher value will never cancel with a very low value. Am I right? Right. A very higher value will never cancels with a very low value. There is no chance at all, which means that whatever I have given a tick will be here, whatever I have given a tick will be here. These are the possible places of an equilibrium position. Now based on the analysis of the equation, I can say F1 attains a reasonable value because one is high, one is low. So F1 will come to a middle value. Here also F2 will be going low and F2 will be going high because of the numerator and the denominator. So F2 can also attain a reasonable value, a middle value. Because of these two, F1 may equal to F2. There is a chance. But when come to right side, denominator is very less. So if not less, I mean L plus X, X is very less, L plus X is very high. If denominator is high, force is less. Numerator is also less, force is less. So F1 is too less. But in case of F2, denominator is less, so F2 is higher. Numerator is higher, so F2 is further again higher. So a lower, very low value of F1 will never cancels with very high value of F2. Both will never cancel because one is too low, one is too high. That will cancel? No chances. If both are some reasonable value and if both are acting in opposite direction, there is a chance of cancellations. Now whatever I have given a tick will be, I am crossing this one. I am saying like that right side, which means the positions right to the higher charge will never become a equilibrium position. The intermediate positions, the positions between the two charges, the intermediate position will also not become an equilibrium position. Then we have only one chance. Now out of all the three options initially will come to two options, left or right. Now right is also going out of scope. So we have only one position, that is the leftmost position. So these positions may act as an equilibrium position. This point will act as an equilibrium positions. Okay, so remember, when the two charges are in opposite nature, the equilibrium positions are the left of the smallest charge. Left of the smallest charge. We will conclude. But if two charges are equal sign, then the third charge Q0, which we are going to place it, and that is going to in equilibrium positions, definitely the position is in middle of the, not in the middle, the intermediate position. I mean, between these two charges, the third charge will come to place an equilibrium position. And the important point is the equilibrium position is always very closer to the lower charge. Here also it is very closer to the lower charge. But if both are opposite sign, means it is left side. If both are equal sign, means definitely it is in between the two charges and closer to the lower charge. This is the whole concept behind these two. So here I told you a shortcut methods to find out if two charges are equal, what is the value of x. Here also we have an x, right? For this also we should have a shortcut method. So this x also I am going to write x will be equal to, only small difference will be here, root of q low whole divided by root of q low divided by root of qh minus, here it is plus, root of q low, and into the distance between the two charges. If you multiply this one, you will get the right value. This is the concept behind this. This is q low, q high, q low. Do not confuse between. Okay, these two formulas are same because of the sign conventions difference here. One is become negative, another one is become positive in the denominator side. Okay, here it is positive, here it is negative. Always high minus low, numerator is always low. So this is a concept we have learned. When two charges will be placed and the third charges may comes to an equilibrium positions, depends upon the sign conventions how these are changed. Now we'll summarize the things. Before that, we'll going to see, we'll going to do an examples with this one, and based on that we'll try to solve this. We'll try to see whether our shortcut methods are matching with our concepts. Okay, so let's solve this first. So I'm keeping the what I can say, the shortcuts method as like will be there, and we'll apply these concepts will be here, and we'll try to find out this x, I mean the normal equilibrium positions in a normal way. Then we'll see our shortcuts methods are holding good, will be here or not. I'll keep it here itself. Okay, so let's move. So as I told before, we have two charges will be here. Just I'm taking q and I'm taking minus 9q. So q and minus 9q, distance between them is L. Definitely I know if such kind of questions are coming, if they're asking where I have to place the third charge in order to come to an equilibrium position, I'll say towards left side. So the left side distance I'm calculating as x. Okay, now the third charge is considered as q0. So because of q, two forces will be there. Because of q, F1 towards left, and because of I'll put it like this, because of minus 9q, a force will be towards left. This is F2 and this is F1. Okay, so this will be the, what is the value of F1? F1 is because of this one, 1 by 4 pi epsilon 0 q into q0 divided by x square, and F2 will be equal to 1 by 4 pi epsilon 0 q into q0 into, what is the other charge? Minus 9q. So 9 into q I'm putting here. What's the total distance between them? L plus x the whole square. Okay, two forces are equal. If two forces are equal, only the equilibrium positions will come to picture. So both are equal. Both are equal means what are the terms will cancel? 1 by 4 pi epsilon 0, 1 by 4 pi epsilon 0. I am equating F1 and F2. What else will be cancelled? Q, Q0. Here Q, Q0 will be cancelled. So we are taking the total things will be equal to how much will be coming? What will be the here the numerator? 1 by x square will be equal to what will be here? Minus 9 divided by L plus x the whole square. Okay, L plus X the whole square. Now for easy understandability purposes, for example, I am taking F1 and F2. So F1 and F2 are the two forces, and the resultant of the two forces will be equal to 0, which means the total force will be equal to 0. So 1 by x square will equal to minus 9 divided by L plus X will be the whole square. Here, what is this minus indicator? Forces are in equal but in opposite direction. So as of now, I am taking the modulus will be here. Okay, because the negative signs indicate the forces are in opposite direction. So I know it is already in positive, because of that I am giving the negative signs. So now I want the magnitude value of x. So 1 by x square equal to 9 divided by L plus X the whole square. Taking the square root on both sides, what will come? 1 by x will be equal to 3 divided by L plus X. We have to simplify this one. So we'll cross multiply these two terms. So L plus X will be equal to 3x. So this will go to the other side. So what will come? 2x will be equal to L. X will be equal to L by 2. So x is equal to L by 2 is the positions. X equal to L by 2 means this is L by 2 distance away. The third charge will comes to an equilibrium position. Now we'll substitute in our shortcut formula. We'll see whether we are getting the same answer. Root of what is the low charge? Q divided by what is root of high charge? 9Q. Okay, here also you have to place your magnitude wise, minus of root of Q. Okay, so this is also Q, this is also Q. So all Q's will be get cancels. So what will come balance for us? Root Q will 1 divided by what this will come? Multiplied with L. What is the value of this one? 3. Okay, so 3 minus 1 into L. So how much will come? 1 by 2, which means L by 2. So whatever our shortcut methods are yielding is same as what we got by our normal method. Normal method in the sense we find the forces on Q0 because of Q, that is called F1. We find forces on Q0 because of minus 9Q, that is called F2. So we know two forces are equal. We can equate these two forces. Here you don't want to put a negative also, because negative indicate the forces are in opposite to that of this one. So here itself you can take the modulus, or you can go and take it here itself. It's up to you. You can take how you want to do the same way. So 1 by x square equal to 9 divided by L plus X the whole square. So taking the square roots on the both sides, and we are simplifying, we got x equal to L by 2. The same value you will got it when you are substituting in this formula. Okay, so hope you understood the equilibrium position of a third charges, where it has to place when two charges, the other two charges will have same nature or different natures. Now this is a concept of two charges are in opposite sign. Now we will summarize the two concepts what we have learned. So write down on your notebook. I hope you have written till here. If not, pause the video and continue to write, okay, one by one. Then after that we are going to summarize this one. Now we'll summarize this concept, whatever we have learned, in a short summary as a short note, so that easy to recollect. Okay, so two cases we have learned. Equilibrium of the charged particles, two cases we have learned. So basically we have our concept is called equilibrium concept. Okay, equilibrium of third charge. I'll put equilibrium of third charge between other two charges, Okay, here we have two cases will be there. Two charges are equal. And here two charges are unequal, which means both are not equals. Okay, for my easy understandability, I am placing QL and Q high. Okay, the distance between them is L, and the third charges, and here two charges are unequal, so this plus one chance, and the chance this minus, this is for you easy to remember, that's all. So QL and Q high here also, but this one is plus, this one is minus, or this one is minus, or this one is plus, opposite sign. Okay, now the third charge Q0, where we have to place the third charge. Q0 has to place in between QL and QH when two charges are equal in signs. Okay, and what is the value of X? X means what? X is the distances from the, so QL will be here, QH will be here. I am placing Q0. Q0 is what? Very nearer to the lowest charge. So Q0 position is like this. So that is important. So you have to highlight. This is our Q0. This position is important. Okay. What is the value of X? X will be equal to root of QL. QL divided by root of QH plus root of QL. This is important. This is what you want to use it for Neet and JEE. Okay. You are not supposed to use for it or board examinations. You will get the answers, but they are expecting in a theoretical format. Okay, so we'll see. And here also both the charges are equal or unequal. Here it is unequal, either positive one and another one is negative. So similar to this one, I'll draw a diagram. So here we have QL will be here, and here we have a QH will be here. Both are same sign. So where I have to place? I have to place Q0 at a distance of X meter from lowest charge, and the position is where? Towards left side, not towards middle, not towards right side, not towards any intermediate position. It's always towards left for the lowest charge. Okay, so lowest charge, this is and center position or an intermediate position, or Q0 in between QL and QH. What we can write will be here Q0 towards left of Q0 towards left of QL, always Q0 towards left. This word is important, left. Here this word is important, in between QL and QH. Okay, if both are opposite, then left. Now similar to this X, what is X formula will be here? Root of QL whole divided by root of QH minus root of QL. This is important again. Okay, this is a summary what we have seen in this session from equilibrium. Equilibrium of the two charged particles will be there, and whenever a third charged particle is placed into the two charged particle system, then where the third charges has to place so that it should attain an equilibrium position. This is the concept behind the equilibrium concept. Now there are other things will be there in the Coulomb's law. So hope you understood what is the concept of equilibrium, and we are moving to the next topic. So already we have learned about the concept which means the comparisons between the gravitational force and electrostatic force. Next topics we are going to learn about what is the limitations of Coulomb's law. Coulomb's law will have certain limitation. Coulomb's law is not a full-fledged law, so it has certain limitations. So write on the next heading, the limitations of Coulomb's law. Limitations of Coulomb's law. Gravitational law, that we have what we have seen, what we have learned in Newton's law of gravitations. F is equal to G m1 m2 divided by r square. Coulomb's law we have learned in electrostatic. F is equal to 1 by 4 pi epsilon 0 q1 q2 by r square. Same way here also, like this rule or this law will have certain limitations. So write down the headings on your notebook. Limitations of Coulomb's law. Coulomb's law. Coulomb's law. Limitations of Coulomb's law. L-U-L-O, whatever you want, you can place it. I don't remember exactly, I think it's O. So Coulomb's law. Okay, so the first one, Coulomb's law is applicable. Coulomb's law, I'm putting CL for easy simplicity. So Coulomb's law is applicable. Coulomb's law is applicable only for point charges. Point charges. What this means? Point charges means if I have one charge Q1, this is just a point. I have another charge Q2. Can I apply Coulomb's law? Yes, Coulomb's law I can apply. So this is meaning of point charges. Suppose I have a sheet of charge, a sheet content. This is one sheet. S1 sheet. I have another sheet will be here, and this is an S2 sheet. Okay. So here large number of charges will be here. Here also large number of charges will be here. Can I apply Coulomb's law between these two charge sheets? It's not possible. Which means that's what Coulomb's law states, that my law can use only for the point charges. Whatever this is called extended charges. This is point charges. When we have a collection of points, then it's called an extension. So Coulomb's law is applicable only for point charges, but we know internally, and not applicable for extended charges. Extended charges. This is not applicable for extended charges. That's internally means it is only applicable for point charges. And the second point, note on the points, write down along with me. Second point, this law can't be used when two charges are moving. When two charges are moving, which means this law is applicable only for stationary charges. Which means you write it. Which means this law applicable for stationary charges. Only for stationary charges, not for moving charges. But here I have to say one exceptional cases. What this second statements indicate is applicable for stationary charges, which means both the charges should be stationary or any one will be stationary. That is a point, right? So here, if one charge is moving and another one is stationary, this law is applicable. When two charges are not moving, this law is not applicable. So this law can't be used when two charges are moving. Here, when two charges are moving, within bracket, you can just add two charges. When two charges are moving, I cannot apply. The third point will explicitly write, if any one charges moves, if any one charges moves and the other charge in rest, then this law can be used. So three important points on Coulomb's law is applicable only for point charges like this, 2 points, and Coulomb's law not applicable for extended charges. Hope you understood what's the difference between point and extended charges. Second one, this law can't be used when two charges are moving. Okay, I have already written when two charges. You can additionally write two charges. When two charges, this is not required, right? Already we have mentioned here two charges. If you mention also, it is okay. When two charges are moving, this is not applicable, which means this law is applicable for stationary charges. Third point, if any one charges are moves and other charges in rest, then this law can be used. Here we have an applications will be there. One charge is moving, another charge is not moving. There are certain situations or certain cases are there. We need to analyze it as a next topic. So hope you understood Okay, how the two charges are two charges cases we can apply the Coulomb's law, and the two charge means which are point charges, not extended charges, and it's applicable for stationary. Stationary in the sense either two charges are stationary, you can apply Coulomb's law. If one charge is moving, another charge is rest, then also you can apply Coulomb's law. If both charges are moving, then you cannot apply Coulomb's law. Okay, this is a limitations of Coulomb's law. We'll move to the next topic. Okay, this is the last topics in the Coulomb's law session, and as I told, like in the last topic, the limitations of the Coulomb's law, the third point is like, if two charges are there and if one charge is moving, another charge is not moving, still you can apply the Coulomb's law. We'll see one example for this one and write down the heading Coulomb's law with SHM, simple harmonic motion. Hope you have remembered simple harmonic motion. You have learned in your school class also, like first year. If you're not remembering also, it is fine. First we can learn it here itself, some few basic things. Okay, so Coulomb's law with simple harmonic motions. Let's take an example. Suppose I have a Q charge will be here. I have one charge. I have another charge will be here Q. Both are positive charges. Okay, now I am going to place a third charge. Third charge will be here. The distance between them is marking as 2a, so the middle distance is a. Now if I immediately place one charge, Q0 will be here. What will happen? The left side, because of the left side Q2, and there is a repulsive force will be here, and because of this Q, there is a repulsive force will be here. Okay, suppose now I am assuming because of the left side Q, this body is moving towards right side with a force called F2, and because of the plus Q on the right side, there is a repulsive force. So what is actually happening here? It's like, listen very carefully. First let's forget about all these arrow marks will be here. I just placed one Q0. What will happen? When this Q0 will be here at the middle position, not at the middle position, at the intermediate position between the two charges, because of this Q0 will attract or repel. I am assuming this is also positive charges. So what will happen? It will attract or repel. It will repel. So which will repel means this will move towards these directions with a force called F2. Now if it is moving very closer, what will happen? This is also a positive charge, right? Whenever the Q0 will come here on my finger positions, what will happen? This is also plus Q, right? What this will also do? This will also give a repulsive forces. Whenever it is moving will be there, the distance between the two charges is shorter. We know the Coulomb's law equation, F equal to K into or 1 by 4 pi epsilon 0 into Q1 Q2 divided by R square. When distance will be less, force will be more. So because of this Q0 will move towards right. Whenever it is moved towards right, it see the distance between the two charges are very less. So what will happen? Immediately this will return back with another force called F1. Okay, so whenever it is returned back to this position, say again this Q will see, hey, the distance between the two charges are again less, so force will be high. So what will happen? This will again move forward. If this will again move forward, then the distance between the earlier this distance, now this distance, so it is very less. If it is very less, what will happen? This will again move forward. So what will happen? This charge will go forward path, backward path, forward path, backward path, forward path, backward path, which means that it is SHM, simple harmonic motion, like moving a pendulum. It is like moving a pendulum. It is moving back and forth. So now the question is like, suppose it is moving back and forth over a distance of x. Now the question will be here, what I am going to ask you will be here, whenever it is moving a distance of x, what is the net force acting on, either towards right or towards left, it doesn't matter. Then whenever it is moving towards one side, what will be the forces are acting on this one? whatever I am going towards right side is taken as positive and left side is taken as negative. So F2. So F net total force will be equal to F2 minus of F1. What is F2? 1 divided by total force, tell me, 1 divided by 4 pi epsilon 0. F2 is a force. So total distance is A. Okay, this is moving towards right. How much distance it is moving towards right? X meter. So Q into Q0 divided by A plus X the whole square. Total distance between the two charges is 2A. The middle distance, up to the middle, it is A. Now from suppose it from this middle, this is moved towards a distance of X meter. So totally here it is A will come. Initially it is A position, I am assuming. Now it is moved towards an X meter. So how much will come? A plus X the whole square. Okay. Next, the other force will be equal to minus of 1 by 4 pi epsilon 0. Here Q into Q0. The Q into total distance is A. Now it is moved X meter. So what is the total distance between the two? One is A minus X. Here it is X. So what is this distance will come? Here again it is A meter. So A and A total 2A. X is moved. So what is balance? A minus X. Okay, total is A. X gone. So what is balance? A minus X the whole square. So if the total force on the body will be at this point, at this equilibrium position, is this much is the value. Now we have to see what will happen, what is the total force on this body when it is at the X meter. This is actually the total force. We can simplify this mathematical expressions. 1 by 4 pi epsilon 0, Q and Q0 taken outside, 1 divided by A plus X the whole squared minus 1 divided by A minus X the whole square. We'll simplify this one. Okay, so here left side 1 by 4 pi epsilon 0 into Q0, cross multiply A minus X the whole square minus of A plus X the whole square, A plus X the whole square into A minus X the whole square. So 1 by 4 pi epsilon 0 Q into Q0. Here A square plus X square, A minus B the whole square minus 2AX minus of A square plus B square plus 2AB 2AX whole divided by A plus B into A minus B, A square minus B square format. So what will come? A square minus X square whole square, because here square, here also square. Next, A square cancel, here also it's minus A square, X square cancel, X square cancel, minus 2AX minus 2X, totally how much will come? 4AX. So 1 by 4 pi epsilon 0 Q into Q0 into minus 4XA whole divided by the denominator part, A square minus X square the whole square. Next, here if you see will be here comparable to A, X is very lesser. Okay, further steps are simplifying here. If you are not writing, pause the video and write it. Rest of the steps are writing here. Okay, so we know A is greater than X, so X can be neglected. Okay, so X is less. If you are taking X square, a less number like a 0.1 in a square, so 0.001. okay, 0.1 square. So if you are going like 1 by 2 means 0.5, 1 by 2 square, what will come? 1 by 2 square, 1 by 4, 0.25. So the same problem. Okay, so when X is very lesser means denominator X square is too less, so we can neglect that. So what will come? One balance 1 by 4 pi epsilon 0 Q into Q0 4AX negative whole divided by A square minus X square, X square removed because X is small, X square is too small, A power 4. This will get cancelled. So what will come? 1 by 4 pi epsilon 0 negative signs will be here, Q into Q0 into 4, A is not coming, X whole divided by A power cube. This is the total force acting on the body when these charges are undergoing what type of motion? SHM, simple harmonic motion. When the charges will undergo simple harmonic motion, two charges will have equal magnitude. If I place the third charges, it will move back and forth. That is called SHM. Now, if you analyze the third limitations will be here. Two charges will be there. So, I am going to find out the force between the two charges. One charge is moving back and forth because of what motion? SHM. But the other charges are rest position. In this case, we can apply Coulomb's law. This is what we are done will be here. Okay. Here the negative signs indicate means F1. I told whatever I am taking towards left is always negative, whatever I am taking towards right is positive. So the negative signs gives to me the total force on the SHM body, simple harmonic motion body. What is the motion body will be here? Not body exactly, we can say motion charge. What is this motion charge? The total force on the motion charge is negative, which means when it is comes to x distance towards right, it will move towards left immediately. So if you are applying the same case towards left side, then you will get positive, which means from here this should move towards left. Now we have taken x meter, we are assuming it is moved towards right side, and based on that we got the final force equation is left side, which means when it is at this position, a total net force will act this much quantity, and the sign indicate the forces are opposite to F2, which means in the F1 direction. So one charge is in rest position, another charge is in moving position, can still apply the Coulomb's law. But two charges are moving cases, we cannot apply Coulomb's law. And when two charges are point charges only, we can apply Coulomb's law. For extended charges, Coulomb's law is not applicable. This is all about your second part of electrostatics chapter, which is called Coulomb's law. Now you have already seen like a Coulomb's law, the first part of the video. You have seen the second part of the video, and this is the third part of this video. And now the Coulomb's law section is over. Next class we will move to electric field, the next part of the first chapter. First chapter is a very elaborated one, but understand it in a concept wise. So all the things whatever I told it to you in the first part, second part and the third part of Coulomb's law are very important. There are questions are already came for Neet and JEE examinations from various sessions, various topic under this Coulomb's law. So definitely keep on watching all this three part 1, part 2 and part 3 videos. If something is not understandable or nothing is not understandable, please watch it again and again and make it clear, maintaining a proper notes and keep it the things in a proper shape, especially the shortcuts methods, whatever the things I have told, and understand the concept. Okay, then we'll wind up for the third part of Coulomb's law. Okay, thank you.